Hello, in this video we will introduce logistic regression. So we know in the previous videos we have introduced with many videos of linear regression. So the linear regression wants the continuous response variables as dependent variables. But in many socioeconomic cases, the response variable is not continuous and also not normal. So one example is the binary case. So for example, in the Bernoulli process, we get the results 0 or 1, or success or not success, or success or fail. We only get these discrete random results. So how to model these kinds of response? So if we look at the probability of binary case, so the probability can be a function of independent variable and beta is a parameter. And if we also look at the variance of the response variable, so in the linear regression, we have assumption that the variance of the response variable is not connected with the independent variable's value. So which means no matter which kinds of the magnitude of x, the response y in the linear regression has constant variance. But in Bernoulli process, the binary response variable, we get the probability of this occurrence of 0 or 1 is the function of x and beta. And Bernoulli variance is p multiplied with 1 minus p. So this, because p is the function of x, so this part is also a function of x. So which means the variance is not constant in terms of x value, right? So that's why we cannot use linear regression to model the binary response case. And one approach to model the binary response is using logistic regression. So this is a probability, and this part is 1 divided by 1 plus e's in the power includes x variable times beta. We write quotes here because usually x can be a vector of multiple independent variables, and this is a column vector. So x quotes will be a row vector and beta will be a column vector. So the row vector times column vector will be a constant, will be a scalar. And remember, there is a minus sign here. So from this expression, so if x is very big, so this part will be close to 1, or close to 0. So the result will be almost 1. And if x is very small, or we say x is on very big negative number, so this part will be very big, and the results of the probability will be close to 0. So if we look at this figure, now this is called logistic or S shape, and x very big, then the probability will be close to 1, and on contrary case, the probability will be 0. So this is perfect to model the probability using logistic regression. So the purpose of this model is to estimate the beta value. This is similar as the linear regression, but the difference is this part is in the exponential part and in the denominator. An estimate of a logistic regression, we use log likelihood. So we show an example. So here is for dose of medicine to kill insects, and this is a different dose with grams, and this is a total samples or total insects and how many insects was killed in this group of sample, and this is a percent, or we say this is one kind of probability. So how to estimate this model? If we write NP, because the binomial distribution actually comes from Bernoulli process, and the Bernoulli process is the 0-1 for the one time experiment, and the binomial is for n times of Bernoulli experiment. And for binomial distribution, NP, so n is the total example and p is the constant probability. So this NP is the mean of this group of sample. And because p is connected with the x and beta, so we can write EY or NP, the mean of this group of sample, will have this expression. So if we look back, so here this one is NP, this one is another NP, it's also NP, but different n and different probability. Because p is connected with xi. So here this is x. So you can see with a different x we can have different p, right? But how to estimate this model? Estimate this model using the log likelihood. What is the log likelihood? So likelihood actually is a very simple idea. So this means what you have seen, this happened, example, this is 47 and 8 killed. So we get this 8 killed, 8 sample. Remember this 8 sample killed, and we just multiply all the probability of these 8 samples. We only focus on these killed samples. Then multiply all these samples, the probability, then take log sum. Take a log. So why we have to take a log? Because if we multiply this 8 and multiply with another 14 with 24, this will be very, very a small probability, right? And this is maybe several hundred examples probability projection. And this expression is quite difficult to estimate the parameter, because we want to maximize this likelihood with respect to the parameter beta. Because you have seen this occur. So log likelihood's idea is you have seen this occurred because parameter makes this has maximum probability to occur. So this is the idea of estimating these parameters. So we just multiply all probabilities of this old sample, and of course the probability includes expression with x in a logistic regression. So we multiply all the probability together, then take log sum. Then because take logarithm, the production will be transformed into summation. So this is much easier to estimate. So in practice, estimation of such log likelihood expression will be in a program software like SAS. So here SAS SAS logist will get this log likelihood estimated. So the result is beta 0 and beta 1, both significant under the p-value less than 0.0001. So both are significant. So in the end, we get this logistic module is 1 plus E minus the inside the power is minus 1.7361 plus 6.29454 times X. So which means for the different values of X, we have different probability from logistic expression, right? And because we get so many samples killed from these trials, and each trial gets different number of killed. So here killed number is how many get Bernoulli positive, right? And why we get so few and this is so many? Because different number of X. So X is related to probability of killed. Then after the log likelihood estimation, we get the parameter of this X. This is beta 1 for the X, and we have another constant or intercept beta 0. So in the end, we have this logistic regression expression. So we will not go into advanced topics of logistic regression in this video, and in the later video we will discuss some aspects or characteristic of the logistic regression if you are interested in these kinds of module to model the binary response variable. Thanks for watching.